All right. So I'm going to be talking about the overview of the assessment process. We have scales of the assessment, the spatial and temporal variability, what to do about created and modified natural stream channels, and also some other disturbed situations. So our assessment reach, or the assess scale of the assessment, is the reach. The reach length is determined based on the mean bankfold channel width. And so it'll be 40 times the mean bankfold width. And bankfold width, as you recall, is one of the indicators. So you will use it not only to help predict flow class, but also determine over what your scale of assessment is. The minimum length will be 40 meters. We use that minimum length because some of our indicators, you need to have a certain amount of area in order to sample, get enough of that measurement to make sure that you didn't overlook an indicator that might be present. And we have no longer than 200 meters. So if you're dealing with a really wide channel, the maximum length will be 200 meters length. You want to properly size that assessment in order, like I said earlier, to see that indicator. In multi-threaded systems, we don't really run across this as much probably in the east as we did in the arid west, or in areas where we had really high and steep channels flowing into low topography. But you want to include the entire active channel in estimating the assessment reach. So measure from bank width to bank width across that entire multi-threaded section. Most indicators will probably be observed in both the primary and the secondary channels. There's going to be several factors that determine variability of stream duration. Some of these are some of our measures of indicators, such as change in slope and valley confinement. When those things change within the reach, you're going to want to maybe shift your reach to align with those major changes. And we'll discuss some of this in a few slides. But these are different ways in which you want to, or different items in which you want to characterize, use to characterize where you want to start and stop your assessment reaches. So depending upon your assessment area, you may have more than one reach in which you'll apply the SDAM. So where should you place your assessment reach? You want to, it'll be based upon where you need to do an assessment, but where you draw those lines and separate them will be based on the drivers of flow duration. So if you have a transition, such as a small waterfall, for instance, and you go from flat channel slope to a steeper section, back to a lower slope section, you may want to have more than one assessment reach. Don't let the presence of surface water determine where you assign that reach necessarily. So you want to base it on things that you know that would be drivers of that, like topography, a presence of a tributary coming into a stream, or a pipe that's discharging water. Those are sort of the characteristics that you want to use to set your assessment reaches. And we definitely don't want to trespass or get on private property without permission. So keep that in mind when you are setting your assessment reaches. Some applications don't allow for discretion. Assess the reach within the specified project area. So this is what I was saying earlier. You may be limited in where you can apply it. You may want to sometimes include road crossings, tributaries if you have to, but ideally you would not like to include those. This may require assessing a relatively heterogeneous reach with a subsection exhibiting different flow duration. In these cases, portions of the longer flow durations will have a larger influence, because that's where some of our indicators like macroinvertebrates will be more abundant, more prevalent. And so keep in mind when you do the assessment that you may, across changes in flow duration, they will reflect the sections that may be a minority of your overall assessment reach. So how many reaches are needed? One is sufficient for small project areas, but you may need more than one if you've got a large area or a large area with a lot of diversity in channel morphology or changes in drivers of flow duration. You want to place them above and below the major transitions, such as these major tributaries that I mentioned, or road crossings. Oftentimes roads are associated with drainage ditches, which then sort of alter the local drainage patterns, making one or more places different in having sources of flow. So can you use disturbed channels? Yes, you can use disturbed channels. We purposely tried to include range in stream channels affected by upstream and adjacent land uses. So that way we would be building a tool that could be used wherever possible. So you can use these in disturbed channels. We have streams with urban land use adjacent to sites, agriculture, cattle grazing, forestry practices, you name it, as well as natural environments. So non-point source pollution, effluent discharge, habitat alteration, all these things, as many of you will know, affect some indicators such as macroinvertebrates, which are often used as an indicator of water quality or stream condition. Inputs of large inputs of fine sediment and armoring from riprap and such things will affect our SDAMs, because we have those indicators. However, these will be considered in our model, because we had sites with those kinds of disturbances that would affect those. So we encourage you to note those conditions when you are doing your assessment. There are places in the report in which you can include that and use that to help you decide how much confidence you have in applying the SDAM under those conditions. Short-term disturbances or pulse disturbances like floods or clearing due to vegetation trimming, maintenance along stream channels. Those can temporarily remove indicators that would be useful for your assessment. Most indicators will come back, so you may have to wait and return to a site for a few weeks for some of those to recolonize the reach. Under severe conditions, you may want to note what you observed during the site and make a note of how that might affect the indicators that you're scoring. So when should you do the assessments? The peak growing season is going to be the best, because we have indicators such as presence of upland plants in the channel. So during the growing season, that might be ideal, as opposed to the scene shown in this photo with snowfall and ice on the channel. Some conditions like that also make it difficult to see conditions on the stream bottom and to collect macroinvertebrates and other indicators. So ideally, having conditions during the growing season would be great, but our study did incorporate sampling under conditions such as shown in this photo. So some of that variability is built into our model.